Assalamualaikum. We are from JCS 1434B. So we would like to explain about elementary linear algebra. First, for introduction, Gauss-Jordan elimination method is known as back substitution method. The way to apply this method is convert the row echelon matrix to a system of linear equations. The matrix will be reduced to a reduced row echelon matrix, and at the end of the reduced row echelon matrix will be converted back to a corresponding system of linear equations. Then the solution will be done. In our case study, we decide to find the amount of hours spent for all sports observed at first, second, and third day. From the problem, we want to use Gauss-Jordan elimination method in solving the problem. Even the problem actually can be solved by adding all of the values, but we are required to use such method to observe more about the method well. Then, the objective. The objective is to find how many hours spent for all sports started at first, second, and third day by using Gauss-Jordan elimination method. The question is, Ahmad leads a survey about how many hours that UATM's Gamma athletes spend to train themselves for their coming game. Ahmad recorded the numbers of medals that they have got in a year. Here is the result that Ahmad got from his observation and investigation. So this is the table, and we are required to find how many hours spent for all the sports started at first, second, and third day by using Gauss-Jordan elimination method.
Okay, so hello, I'm going to explain about the solution. Okay, so step 1, form an augmented matrix corresponding to the above system by following the equation 6x plus 2y plus 2z equal to 4, 12x plus 8y plus 6z equal to 10, 3x plus 13y plus 9z equal to 3, and 6x plus 4y plus z equal to 18. So first day stands for x, second day stands for y, third day stands for z. Okay, so here's the matrix. Okay, move on to step 2. The first non-zero entry in the first row must be number 1. But in the augmented matrix, the first non-zero is 6. To change it, multiply the first row with 1 over 6. So after multiply the first row with 1 over 6, it will change to 1, 1 over 3, 1 over 3, and 2 over 3. Step 3, the first non-zero entry in the first row is 1, and this is the leading one for the first row. So we need to zero out all the entries below this leading one. So firstly, we multiply the first row with negative 12 and add it to the second row. Next, multiply the first row with negative 3 and add it to the third row. So the second row has been changed to 0, 4, 2, 2, and the third row changed to 0, 12, 8, 1. Step 4, proceed to the second row. Since the non-zero entry is 4, multiply this row with 1 over 4 to get leading 1. So it will change to 0, 1, negative 3 over 2, and 1 over 2. Okay, step 5. All the entries below the leading one in second row need to be zeroed out. Multiply the first row with negative 6 and add it to the fourth row. Next, multiply negative 1 over 3 to the second row and add it to the first row. So the fourth row will be changed to 0, 2, negative 1, and 14, while the first row will change to 1, 0, 5 over 6, and 1 over 2. Next, step 6. Proceed to the third row. The non-zero entry is 12, so we multiply the second row with negative 12 and add it to row 3. Same goes to row 4, which is 2. Also multiplies the second row with negative 2 and add to row 4. Because all the number below the leading must be 0. So the third row will change to 0, 0, 26, negative 5, and fourth row will be changed to 0, 0, 2, and 13. Alright, next step 7. According to the rule of Gauss-Jordan, all leading one must be diagonal. So we need to multiply 26 in row 3 with 1 over 26 in order to get leading one. And lastly, step 8, multiply row 3 with negative 2 and add to row 4 to get 0. So now the step is complete. So this is the last step of the augmented matrix. Okay, so that's all.
So next, this is the step that I already explained earlier. So this is the solution from the step given. Assume x, y, and z are the sum of t value. X equal to t, y equals to t, because x and y only have a value of 1. Meanwhile, z equals to 5 over 6 plus negative 3 over 2 plus 1t equals to 1 over 3t. To find t, sum up all of the value and equal to t value. For first day, 6 plus 12 plus 3 plus 6 equals to t. This is from column 1. So t equals to 27. For second day, 2 plus 8 plus 13 plus 4 equal to t. So this is from column 2. T equals to 27. For third day, 1 over 3 actually equals to 2 plus 6 plus 9 plus 1. So 1 over 3. T equals to 18t. So t equals to 54. So next is substitute the value of t into the equation of x, y, and z. For first day, x equals to t equal to 27 hours. For second day, y equals to t equal to 27 hours too. For third day, z equal to 1 over 3t equal to 1 over 3 multiplied with 54, and the final answer is 18 hours.
Now we finally at the end. I am surely that my friend have explained all steps on this method clearly. The main objective, which is to find how many hours spent for all sports state at first, second, and third day by using Gauss-Jordan elimination method, already achieved. We define the hours spent for all sports which are at first and second day at 37 hours, while on the third day was 18 hours. We also know how to apply this method in solving problems in daily life. We hope that you guys can also understand and relate this method in solving problems. That's all from us. Thank you.